Hello everyone. The title of this video is Multiply Complex Numbers. Okay. Every exercise I do in this video is taken directly from a free online textbook at openstax.org, and it's their Intermediate Algebra Text 2nd edition, section 8.8. Use the complex number system. I'll be working under the heading Multiply Complex Numbers, and I'm only going to be working on the even numbered exercises, starting with number 430, then going to 432, 434, 436, etc. All the way down to 456. I will have, and I'm doing these because they don't have solutions in the book. You may notice that all the odd numbered problems you can click on, they have a link, and you can be taken to the solutions. So I'm going to work on the ones that don't have solutions. I will also have timestamps in the description for each example, each exercise I do. And the example 1 timestamp will correspond to number 430, example 2 to number 432, example 3 to number 434, and so on. So if you'd like to count down, to a particular example that you'd like to see, you can then click on the timestamp for that example. Alright, and one request I have of you is that when I bring up a new question, pause the video and try to do it yourself first before watching me do it and then comparing. Because if you're just watching me do these questions and not practicing yourself, chances are you're not learning all that much. Okay, so the first exercise I'm going to do, first example, is number 430. I've got these written out. And we're just asked to multiply and of course simplify if necessary. So this is example 1 corresponding to exercise 430 from the text. Alright, so we have here 2 times I multiplied by the quantity, a sum, negative 3 plus 4i. Hopefully you recall what I represents. Remember, this I is the imaginary unit. It is the square root of negative 1. So in other words, it's a number that when squared would give me a negative number, would give me negative 1. So keep this in mind. I is the square root of negative 1, meaning that I squared will give me negative 1. And then when you're multiplying complex numbers, numbers with imaginary parts to it, multiply just like you would multiply polynomials. You just use polynomial multiplication. And treat I, just like you would treat x. But the only difference is I is not a variable, I is a specific number. So let's do that. So I'm going to be distributing 2i here. So we'd have 2i times negative 3, which is negative 6i. Again, just like if you were doing 2x times negative 3, it would be negative 6x. And then 2i times positive 4i would be positive 8i squared. Alright, now this is great and everything, but we shouldn't ever be seeing powers of I higher than 1. And the reason for that is, whenever I is raised to a second power, that's just negative 1, by definition of this I. So this is negative 6 times I, plus 8 times, and then I squared is negative 1. And so we have, I'm gonna put it in standard form. Okay, so again, kind of another recall over here. Remember, the standard form for a complex number was a plus b times I, where a and b are real. Right, so you have a real number plus a real number times this imaginary unit. Let me box that in also. Alright, so the real number part of this would be positive 8 times negative 1. That's negative 8 for the real number, plus the imaginary number, which is, negative 6i. Alright, so you can leave it like this. That's totally fine. It's just, usually when people write plus and negative, it's just minus, right? So I'm gonna leave this at the end as negative 8 minus 6i. Let me circle that. That should be my final result. And I want to put all my final results in this standard form for a complex number. Wonderful. Now, to check. Right. Now I'm going to check with a calculator. Right. You don't have to if you want to just factor this. As long as you can factor it to look like this again, you should see that they're the same expression. But I'm going to pull up, I have a TI-84 emulator, TI-84 Plus right here. And currently, if you look at the top, see it says normal, float, auto, and then next to that, there's this A plus BI. That means I'm in complex mode. I'm in a mode of the calculator. So you hit the mode button to go and change this. Most people start off with this in real mode, but if you change to this A plus BI mode, then imaginary numbers and all the complex numbers can be displayed on the calculator. Alright, so for example, let me show you the square root of negative 1. If you have it in real mode, this would come back with an error, saying that it's a non-real result. But if you have it in this A plus BI mode, it comes back with I. Right? The square root of negative 1 is I. Right, so now that the calculator actually, we have it in a mode that actually displays complex numbers, we can test our results here. So I'm going to first enter the initial expression I was given, which was 2 times I. Now I is above the decimal point on this, right? So I go second I, right? 2 times I multiplied by the quantity, and then negative 3 plus 4i. Right? And this should end up with, if I did things correctly, should end up displaying negative 8 minus 6i. Let's see. Look at that, right? Negative 8 minus 6i. Perfect. Wonderful. Alright, so I'm only going to do this checking with the calculator for this first page, right? Just these first couple examples, and leave the rest for you to check. Okay. Next question. Alright, so number 2 is the same concept, right? And then we're asked to do the same stuff for all these exercises. Multiply and simplify, and I'm going to express all my answers in standard form. So number 2 corresponds to exercise 432. So no different than number 1. Right? I have this negative I multiplied by the quantity 6 plus 5i. So we distribute negative I. Alright, so negative 1i times 6 is negative 6i. And then negative I times positive 5I would be negative 5I squared. But once again, we have negative 6I, and then minus 5 times I squared, but I squared is negative 1. Right? You should never leave any powers of I other than I to the first. And then negative 5 times negative 1 is positive 5, right? So that's the real number. And then the imaginary is negative 6I, right? So I end up here with 5 minus 6I as my final result in standard form for a complex number. Alright, then once again, I will pull up a calculator and we'll enter the original expression and see if we get that final expression back. Let's move that off to the side so we can see stuff. So yeah, so I'm doing negative I times the quantity 6 plus 5I. And indeed it is 5 minus 6I, like I said. Right? So great, I checked my work, I did a good job. Let's move on. Alright, the next question involves a little more distributing. Right? Again, I'm hoping that you remember how to multiply polynomials. Because we have two-term expressions multiplied together. So number 3, which is 434 in the text. We have something with two terms, right? A real term and an imaginary term, multiplied by another complex number with a real term and an imaginary term. So yeah, lots of distributing, remember, or you could call it foiling when you multiply two expressions with two terms, right? You could do that FOIL method. But so first I'll distribute the negative 2. So then we have negative 2 times negative 4 is positive 8. Negative 2 times positive 3I would be negative 6I. Alright. Now I'm done with the negative 2. Move over to the negative 5I. Alright, and distribute that. Alright, distribute negative 5I. Well, negative 5I times negative 4 would be positive 20I for the next term. And then negative 5I times positive 3I would be negative 15I squared. Right. Right, and once again, just like with polynomials, the imaginaries go together, right? Negative 6I plus 20I makes 14I, so we have 8, and then these two terms together make positive 14I, and then minus 15 times I squared. But remember, whenever you see I to a higher power, you got to change it. Right? I squared is negative 1. Alright, so we have 8, and then this becomes plus 15, right? This right here is plus 15 now. And 8 plus 15 is 23. So the real number is 23, and the imaginary part of the complex number here is plus 14I. And there we go. And once again, you can check it with a calculator. Just enter this original expression, and hopefully you end up with 23 plus 14I in the end. But I leave it to you to check. Right, next question, very similar. Right, multiplying two complex numbers with a real term and an imaginary term. This is number 4, exercise 436 from the text. Alright, so first I'm going to distribute negative 6 to the negative 3 minus 5i. Right, negative 6 times negative 3 is positive 18. Negative 6 times negative 5i would be positive 30i. Alright, now I'm done with that. Move over to the negative 2i, right, and distribute the negative 2i to the negative 3 minus 5i. Negative 2i times negative 3 would be positive 6i. Negative 2i times negative 5i would be positive 10i squared. Alright. So now I have the following: 18. This 30i and 6i can be combined, right? 30, so make 36i, right? Plus 36i. And then plus 10i squared is minus 10, because I squared is negative 1, don't forget. And then combining the real numbers, 18 and negative 10 make positive 8. So I end up here with 8 plus 36i as my final complex number result. And again, I leave it to you to check that. Wonderful. All right, next question. So number 5, it's exercise 438 in the text. We're taking a complex number, right, with a real part and an imaginary part, negative 1 plus 5i, and squaring that complex number. Well, you just have to remember what it means to square something. Now, please don't distribute the power. Powers don't distribute. This is not negative 1 squared plus 5i squared, right, or 25i squared. What it means to square something is, you take that number in the parentheses, you take the base on that power, negative 1 plus 5i, and square it, multiply it by itself. Negative 1 plus 5i again. And then it becomes no different than examples 4 and 3. So first I'll distribute the negative 1 to the negative 1 plus 5i. So we have negative 1 times negative 1, that's positive 1. Negative 1 times 5i is negative 5i. And then I distribute the 5i to the negative 1 plus 5i. 5i times negative 1 is, again, negative 5i. 5i times 5i is 25i squared, plus 25i squared. Alright, so we have 1, then the negative 5i minus 5i, those go together to make negative 10i. And then plus 25 times I squared. Remember, I squared is negative 1. 25 times negative 1 is negative 25. And then I combine the real numbers. 1 minus 25 is negative 24. And then you still have this minus 10i term. Fantastic. And there's my final result in the standard form for a complex number, negative 24 minus 10i. And again, I leave it to you to check that. Alright, the next question, very similar. This is number 6, exercise 440 in the text. So we have here another complex number with two parts, a real part and an imaginary part, being squared. Right, so once again, remember what it means to square something. You take that negative 6 minus 5i, and you're going to multiply it by itself. I'll start by distributing the negative 6 to the negative 6 minus 5i. So that gives me, 36, positive 36 plus 30i. Right. And then distributing the negative 5i to the negative 6 minus 5i, and then we'll simplify. So distributing the negative 5i gives me another positive 30i, and then positive 25i squared again. So we have 36, and then the 30i and 30i make 60i plus 60i. And then 25i squared, just like in number 5, is minus 25, right? I squared is negative 1. And combining the reals, 36 minus 25 is 11. And then you have plus 60i, right? So this is the resulting square of negative 6 minus 5i. It's 11 plus 60i. Great. And once again, I leave it to you to check this. All right. Now in question 7, we don't see the i's right away, but we can make the imaginary unit I appear. Right? So example 7, number 442 from the text. We have the square root of negative 4, which is imaginary, that's not real, the square root of a negative, right? Multiplied by the square root of negative 16. Now before I even start here, we have to remember, whenever, if b is a positive number, I've written this up in a previous video, hopefully you've been watching. If b is positive, then the square root of negative b, right, the opposite of b, which would be a negative number, that's not real. Right? So we can write it as an imaginary number, and every imaginary number can be expressed as a real number times I. So the square root of positive b, right, just the square root of b times I, and make sure the I is not in the square root, right, that's not part of the square root. So yeah, you should be thinking this automatically whenever you see the square root of a negative number. So square root of negative 4 is 2 times I. And it's the square root of positive 4, which is 2 times I. So I have the square root of negative 4 is 2i times, and then the square root of negative 16 would be the square root of positive 16 times I, which is 4i. Okay? And then we multiply. 2i times 4i would be 8i squared. But don't forget that I squared is negative 1. So this is 8 times negative 1, which is negative 8. Alright, so this one I'm actually going to talk a little more about, because people make mistakes quite often when they have square roots of negative numbers. So here's a mistake that would be quite often made with this kind of a problem. Right, this is a mistake. This is an error that I'm about to do. You take the square root of negative 4 times the square root of negative 16. And then they say, oh, I remember that if you multiply two square roots, you can put them together. Use that product property and make this the square root of negative 4 times negative 16. Right? But then, negative 4 times negative 16 is positive 64. And then, the square root of 64 is positive 8, and this is wrong. And the area where it's wrong is right here. they used the product property for radicals. The product property here is used incorrectly. So one more little recall here. Remember the product property for radicals? I'll write it up again just to refresh your memory. Oh, product. Sorry. Product property. The product property for radicals was this. If you take an nth root of a number, multiply it by another nth root, say the nth root of a times the nth root of b, this would be equal to the nth root of a times b. But this was only when the nth root of a and the nth root of b were real numbers. That was the key. Alright. So that property, right, this product property for radicals, this only applies to real numbers. Looking back at this example here, the square root of -4 is not real. Right? It's an imaginary number. Same thing with the square root of -16. Those are not real. So the product property does not apply. You cannot use it. Right? But when you rewrite these, right, so here's the correction. Write the square root of -4 as the square root of 4 times I, right, and then you rewrite the square root of -16 as the square root of +16 times I. These are real, right? The square root of 4 is real. The square root of 16 is real. So I could put those together. Right? We get the square root of 4 times the square root of 16. That'll give me the square root of 64. And then I times I, we multiply and get I squared, right? And then this would be, square root of 64 is 8. I squared is -1, and again I get -8, right? Just like I got earlier. Right? Just like I got earlier, a faster way, but you can, one more time, this is really important. People make this mistake way too often. You can only apply this property to real numbers. All right, so not the square roots of negatives. Okay, I hope that is clear. All right, and then once again, I'll bring the calculator up to really try to hammer this home. All right, so I'm pulling the calculator back up again. And show you, right, take the square root of -4 and then multiply it by the square root of -16. Right? And you're going to see -8, not +8. Right? And again, -8 plus 0i, right? But adding 0i doesn't change anything. This is just -8. -8. Right? Great. And let me show you that the product property doesn't work here, right? So let me show you the square root of, and then I take, -4 times -16 in the radical. Say I applied the product property, it's not going to give me the same number. This is going to give me +8, right? Not -8, which it should have been. Right? The original expression was -8, not +8. So the product property, one more time, does not apply here because these are not real numbers. Okay. So same thing for number 8. All right. Same thing for number 8, which is exercise 444. Square root of a negative, that's not real, times another square root of a negative number, that's not real. So you cannot use the product property here, please. So like I said, this should be automatic. Anytime you see the square root of a negative number, you should immediately rewrite it as a real number times I. Now the square root of negative 64, that would just be the square root of 64 times I, which is 8I. Times, and then the square root of negative 9, going to rewrite as the square root of positive 9, which is 3, times I. So this becomes 8I times 3I. Right. Do that anytime you see, again, one more time. Anytime you see the square root of a negative, that should be automatic. You should do that immediately. And then 8I times 3I would be 24I squared. And remember, this I squared is negative 1. So it's 24 times negative 1, negative 24. Final result. Or, negative 24 plus 0I if you want to add the 0I there. That doesn't change anything. Great. All right. Next question. We're going to do some more, foiling and stuff, but still, the first thing I see are some square roots and negatives. And like I said, so number 9, exercise 446. Whenever you see the square root of a negative number, immediately rewrite it with I. So off to the side here, the square root of negative 12 is the square root of 12 times I. And then if you simplify the square root of 12, that would be 2 times the square root of 3. And then times I. And once again, make sure that the I is not inside the square root. Then square root of negative 75 would be the square root of 75 times I. And the square root of 75 simplifies, right? That would be 5 times the square root of 3. Square root of 25 times the square root of 3 times I. All right, so I'm going to rewrite that in here, right? So we have 5 minus 2 times the square root of 3 times I. And that was the square root of negative 12. Multiplied by negative 3 plus, and then 5 times the square root of 3 times I. Right. And then we do all sorts of distributing, right? It's like foiling. First, I'll distribute the 5 to this negative 3 plus 5 root 3I. All right, so 5 times negative 3 is negative 15. 5 times positive 5 times the square root of 3 times I, that's just 25 times the square root of 3 times I. Now I'm done with the 5, and I move over now to this negative 2 times the square root of 3 times I. I'm distributing that. Alright, so negative 2 times the square root of 3 times I times negative 3 would be positive 6 times the square root of 3 times I. And then negative 2 times the square root of 3 times I times 5 times the square root of 3 times I. Well, negative 2 times 5 is negative 10 times square root of 3 times square root of 3. You only multiply non-radical factors, and you can only multiply radical factors with the product property, right? Square root of 3 times square root of 3 is 3. So negative 10 times 3, and then you have I times I squared. Right. So this last term here really is just plus 30. I hope you see that, right? Negative 10 times 3 is negative 30, but then I squared is negative 1. So you have negative 30 times negative 1, positive 30. Okay. And then combining like terms, your reals with your reals, negative 15 plus 30 is positive 15. And then these two terms go together, right, because they have I attached, and in fact they both have the square root of 3 times I attached. You just add the 25 and the 6. That'd be 31, right, plus 31 times the square root of 3, right, combining those like radicals, times I. Right. And here we go, there's our final result in the standard form for a complex number. 15 plus 31 times the square root of 3 times I. Alright, next question. Same thing. I'm just going to rewrite these right here. This is number 10, exercise 448. We have 5 plus, now the square root of negative 18 would be 3 times the square root of 2, right? That's the square root of positive 18, simplified, times I. And then the next number times, negative 2 minus, and then the square root of negative 50 would be the square root of 50, which simplifies to 5 times the square root of 2, and then times I. Okay, and then I do the same stuff, right? FOIL. We distribute the 5 here, and 5 times negative 2 is negative 10. 5 times negative 5 root 2I would be negative 25 times the square root of 2 times I. Alright, now I'm done with the 5. Move over and distribute the 3 times the square root of 2 times I term. And 3 square root of 2 times I times negative 2 would be negative 6 times the square root of 2 times I. And then 3 square root of 2 times I times negative 5 square root of 2 times I. Well, 3 times negative 5 is negative 15 times the square root of 2 times the square root of 2 is just 2. And then I times I squared. And this last term is negative 30 times negative 1, so it's positive 30. Again, right? It's not always going to happen. It just happened for these two examples that they ended up being positive 30. And then we combine our terms. Negative 10 with 30 makes positive 20. And then these two, negative 25 times the square root of 2 times I, minus 6 times the square root of 2 times I, makes negative 31 times the square root of 2 times I. And there you go. There's the final result in that standard form for a complex number. And I leave it to you to check. Great. Alright, next question. So this question here I'm going to do in a couple ways. Now the first way is the way I've been doing things, right? So number 11, this is exercise 450 from the text. That actually says 450, I apologize. Alright, so here we distribute the 4. We have 4 minus 5i times 4 plus 5i. So I distribute the 4 first. And we get, 4 times 4 is 16. 4 times positive 5i is positive 20i. And then I move over and distribute the negative 5i. Negative 5i times 4 is negative 20i. And negative 5i times positive 5i be negative 25i squared, which this last term would just be plus 25. Right, negative 25 times negative 1. And then in combining like terms, the reals with the reals and imaginaries with imaginaries, 16 plus 25 is 41. And then 20i minus 20i is nothing. So you can write plus 0i if you wish, but it doesn't really change the fact that this is solely a real number, 41. Now, another way to do this one is if you were to recognize that these were conjugates, you might recall multiplying conjugates from earlier videos. If you multiply, say, a plus b multiplied by a minus b, right? So they're the same expression, just a different sign in the middle. You end up with a difference of squares, a squared minus b squared. So that might ring a bell. So for example here, right, we had 4 minus 5i times 4 plus 5i. These are conjugates, where a is 4 and the b is 5i. So I'd end up with just a difference of squares, 4 squared minus 5i squared. Well, that would be 16 minus, and then 25i squared. But remember, I squared is negative 1. So this ends up being 16 plus 25, which is 41. Exactly what I got earlier, multiplying it the long way. So yeah, so if you can recognize that we have conjugates, conjugate pairs here, then you should know that the result will just be a difference of squares. And it'll make it really easy. And one other thing to notice too that'll be useful in future videos on dividing complex numbers. Notice that when you multiply complex conjugates, your final result is real with no imaginary, right? 0i. You're going to watch. Keep watching this happen. When we multiply complex conjugates, the result is strictly a real number with no imaginary part. Right. Next question. Number 12, exercise 452. So once again, I notice that these two expressions here, negative 3 minus 8i and negative 3 plus 8i, are conjugates. And if you recognize that, you can jump straight to here. That the final product will be a difference of squares. So it's like a minus b times a plus b, where a is negative 3 and b is 8i. So end up with a squared, right, negative 3 squared, minus b squared, which is 8i squared. So this is 9 minus 64i squared, which will be 9 plus 64. Right? 64i squared, I squared is negative 1, so this becomes plus 64. And 9 plus 64, 73. But notice once again that when we multiply these complex number conjugates, the final result is solely a real number. No imaginary part, 0i. Wonderful. All right. This is the last page here. Same stuff, right? We're again multiplying conjugates. Number 13, exercise 454 from the text. 6 minus 5i times 6 plus 5i. So this is going to be 6 squared minus 5i squared, which ends up being 36 plus 25. I'm kind of skipping a step here, because this would be 25i squared, which would be negative 25, and then we're subtracting negative 25, making it positive 25. And 36, plus 25 is 61. And that's it. And again, please notice that when we multiply complex number conjugates, you end up with a number that's real with no imaginary part. And finally, the last question here, last example, number 14, exercise 456. Negative 3 minus 4i times negative 3 plus 4i. Again, we have conjugates. So this is going to be negative 3 squared minus, and then 4i squared. Now negative 3 to the second is positive 9. 4i squared would be 16i squared, which would be negative 16 because I squared is negative 1. And minus negative 16 makes this plus 16. Please understand that. And 9 plus 16 is 25. And that's it. All right. And once again, I'll say it one more time. When we multiply these complex number conjugates, you end up with a number that is real and has no imaginary part, right? It has a 0i imaginary part. Wonderful. All right, so hoping that watching me go through these 14 examples here help you in some way when you are asked to multiply complex numbers on your own. And thank you very much for watching.